Hello, I'm Paul Hutton, editor of Smart Highways magazine. We're just getting ready to show you another session from JCT Traffic Signals Symposium 2018. But before, let me just remind you of a few things. First of all, if you're at JCT this year or are affiliated to the organisation, you can sign up for a free copy of Smart Highways magazine. Just go to the link at the bottom of the screen. Also, mark your cards for the ITS UK Summit, 26th and 27th of November at the Bristol Harbour Hotel. It will be a fantastic day talking about implementation. And next year, don't forget, Trafex, 2nd to 4th of April. It is the biggest and best Trafex yet. Don't miss it.
The last presentation in this session is by James Drinkall and Sandra Kamphuis, if I've got that correct, both from SWECO. James is a senior engineer and he has expertise in both signals and ITS. He's a keen ice hockey player and coach and a keen golfer. Sandra as a project manager, and she is also keen on cycling. So they're going to now talk about smart traffic, big data and predictive traffic management services. So it's a subject close to my heart. So would you like to come forward and give your presentation, please?
Okay, so there's a lot of talk in our industry about how we're going to control junctions once connected and autonomous vehicles are introduced onto our network. Well, the SWECO, where we're still been installing mover and scoot, the SWECO smart traffic concept is future-proof. It's planning for connected and autonomous vehicles, whilst also giving predictive traffic management to existing legacy vehicles. Now we do this by using on-site detection that's already there, so your loops, your floating car data, your Bluetooth, all fed into our live predictive model, and this gives the vehicles the most efficient green time. Now here to tell you more about how we use big data in SWECO's smart traffic is my colleague Sandra. Over to you.
Yeah, thank you. It's a good thing that Margaret didn't only pronounce the first names, because my last name is really Dutch. I'm from the Netherlands, and English people, they can't pronounce it because it is Kamphuis, and you can't pronounce the U, so that's a good thing. But I will tell you something about our product, Smart Traffic. I also did something, I changed it around. I will show you something at the end of the presentation that normally people do in the beginning, but I do it at the end. So just wait and see, and you will see at the end. And this is where I start with. I searched a little bit, because with our product we can also reduce the emissions. And the emissions are for a big part based because of the traffic jam, the traffic flow. And I did it for, which city is it? I don't know. Yeah, this was London. This is for TomTom. It is from 2016. TomTom now doesn't have these sheets anymore. But you can look at the congestion level and the amount of delay. And I think for almost most of the cities, it is increased. If you look at 2016 and it's now 2018. And also there was, a couple of months ago, there was an analysis from the UK cities. There are a lot of UK cities ranked high in the top of amount of emission, and I think that's a ranking where you don't want to be high ranked, you just want to be low, probably. And this is what sheet, it explains our product in just one sheet. If we have more questions, we also have a stand here, so you can ask questions after the presentation. But what do we do? This part is more easy. At the left, you see all the input, and the input, what we use it is based on the loops within at the traffic signal. But we also use the system in the Netherlands. We have a short distance radio for buses, but I believe in the UK you have another system that detects buses. That's also our input. But we also use the input that we use is floating car data. In the Netherlands, we have apps that people use, but we also get information from the cars, the floating car data. We get from the buses in the Netherlands and all the emergency vehicles. You have a European communication layer there where they can act, they can ask for priority. But also we have, the last two we made up for ourselves. We have floating bike data and floating train data. In the Netherlands, we also have a lot of crossings with trains near a traffic light. And we see the problem that when a lot of, during the rush hours, a lot of traffic is going to the train when the train is closing, then a lot of, it's this high risk that we have an accident. And we can do with our product, we can predict when the trains are coming, so we can make sure that the traffic light adjusts how they do it. But with all that data, we fill our monitoring. And our monitoring is with all the data, we make an actual view of where the cars are, or the vehicles, or the bicycles, or the pedestrians, just all the information that we collect. And with monitoring, we then predict, within our model forecast, we predict for every vehicle present at the traffic light, we predict when they arrive at the stop line. And then we do with our product, based on the policy of a client, we control the traffic light. So we don't have a fixed loop how you control your traffic light. We just, based on the amount of traffic, we control the traffic light. And then we control the traffic light. We also have information from the top, like the presentation before this one with the bridges. We can get the signal when the bridge is going down or up, and we can control the traffic light based on that the bridge is going down, so we don't send any vehicles to the bridge. Also, for example, with tunnels, when there's an accident in the tunnel, we need to make sure that there are no vehicles entering the tunnel. But also weather, we have, in the Netherlands, we have that the National Weather Company, they can predict, they have 5-minute data, they can say us when it's going to rain, so we can make sure that when it's going to rain, we can adjust the traffic light in how we prioritize, for example, cyclists, maybe more priority when it's raining. And also, if you look at automated vehicles, we are also future-proof. We can send, when we control the traffic light, we can also send information out of the world what the traffic light is going to do. So we can give time to green and time to red. You get in seconds how much time it still is left when you have a change of color. But it's also information we are aiming to send to the automated vehicles, that they can have a box or a time schedule where they can pass the traffic light, so that the automated vehicles know when they can pass the traffic light. And the objectives that I already mentioned, like bike priority or public transport priority. And this is a VISM simulation. We can control the traffic light in VISM. On the left, you see that's how it's now controlled, the traffic light. And on the right, you see smart traffic. When I show this video in the Netherlands, a lot of the times I get the question, we think it is less crowded with smart traffic on the right. But that's not the case. We have the same amount of vehicles, amount of traffic flow. And you see, because smart traffic controls the traffic light in a different way, we have less congestion, less traffic jam, and so we get a better optimization and also less emissions. There's a big junction also with a tram. The green one is the tram passing by. It is in the city center of Rotterdam, so a big city. In the UK there are bigger cities, but for the Netherlands it's a really big city. And these are, in another way, you can see the blue line, that is for how the traffic light is actually now controlled. And the green line is smart traffic. And you see an impressive reduction in the delay of all the vehicles. And the pedestrians and the cyclists are also, this was now based for the cars, but we can do the policy of all the road authority based on, do they want to prioritize more the cars or more the cyclists or the pedestrians? Then you see a difference, but for this simulation it was based on the cars. We also did in Helmond. As we speak, we are testing in Helmond, and we are getting live at the end of today, that we are getting live with our product. But in Helmond we also did a simulation based on the cars. And we see a 22% degree in delay. And we also see with Envivo, we see a 15% delay in emissions. And this is a movie. Here we have an app. You can be an emergency vehicle. The app is not in the store, so you can't use it as a road user, but it is for testing facilities. And this is in Helmond. We have 2 junctions, and we can see that now we are in an ambulance or fire department. And you can see that we get green through both the traffic lights. You can't understand what they're saying because it's in Dutch. It was a Dutch video. This is the first one. And then we have the second one. And you can pass. Our product knows when the emergency vehicle or, for example, a bus is entering, and we make sure that the bus and the emergency vehicle, they get green. The second one is, I have another one. This is our model. We make use of Sumo. That's an open source model. And you can see when this road you see here is the same road that you see in the video. And when a vehicle passes by, you see also the vehicle coming up in our model. One of my implementations engineers was really enthusiastic that he can stand on the street with our model also viewing and playing. And this is the one I told, this is informing the road user. You see the traffic lights here, you can see counting down when it's changing colors. And this is going from, this is Siemens DLC. We control the Siemens DLCs in Helmond. And it's going, we control the Siemens DLC. They give us granted that we can do that in that way. And it goes up to the cloud again. We're in a cloud, and it goes back then to the road user. And within the app, we send out the information. For example, when a bridge is down and you have a red light caused by the bridge, we can inform the road user that it is caused by a bridge. But also when a bus is entering, we can inform road users that you have a red light because the bus is entering. And that way all the road users, they know what is happening, and they understand why they need to wait. Otherwise, they can be annoyed that they need to wait. And you see also the speed and thing, but this is a developing app, but you have apps in the Netherlands where you can see this kind of information where you are at a traffic light that has this information.
Smart traffic. More and more people are living and working in the city. This causes roads to get busier, especially during rush hour. And here you are, in the middle of it, waiting for the next traffic light to turn green. Badly adjusted traffic lights can lead to congestions, causing traffic jams and air pollution. For a pleasant urban living environment, good traffic flow is crucial. This is why we created Smart Traffic. Current traffic lights can only detect traffic once it is waiting in front of the intersection. But Smart Traffic uses multiple data sources to detect incoming traffic. Through these sources, we can predict who's arriving, when and where. The lights can turn green in a smarter way, at a smarter time, enhancing the traffic flow. All intersections communicate with each other. This way, bottlenecks can be detected and solved faster. Simultaneously, we can inform you about green waves. That way you will know if you'll have to speed up to make the next green light, or if you might as well take it easy. And because the traffic will have to stop less frequently and for a shorter amount of time, air pollution will be minimized. The result, you will arrive at your destination a lot quicker, and the city will be a bit cleaner. Smart Traffic by SWECO. This way we plan and design the communities and cities of the future together with our clients.
And this is our product in one sentence. That we optimize the traffic flow today while preparing the city for driverless tomorrow. So, that was our presentation.
Thanks very much indeed. Any questions?
This is primarily about green wave, is it? This is primarily about coordinating across multiple sets of lines, is it?
No, it is, in the Netherlands sometimes we have a hard-coded green wave. What you see with smart traffic, we will do a green wave when it's useful to do. If we see that a lot of traffic going through the green wave, but sometimes the amount of traffic that is coming to the traffic light, a green wave isn't the best option, and then smart traffic will not choose the green wave. It's just based on, yeah.
Mark.
You showed two graphs, one of Rotterdam and one of Helmond, during the morning peaks, or evening peaks, with performance improvements. You didn't indicate how many vehicles had contributed to each of those bits of data. It would be interesting to know, for example, on the trams, whether there were many or only a few, and so what uncertainty there was in your numbers. It would also be interesting to know what performance was like off-peak, to see whether there were also benefits, equivalent benefits under those conditions, so that we have a broader view in the round of what performance you are achieving.
Yeah, we focus on the rush hour at the evening because that's the most crowded hour. But we do in a simulation when we do our projects. We start with a simulation and we do, all kinds of traffic, just what our clients are, and we aim. But the most difficult one is to do it during rush hour. But yeah, we can show with the amount of vehicles and also during the day. Yeah.
Dan praised integrated traffic services in our shells. How quickly does the algorithm adapt?
Yeah.
When it sees changes, I mean, is there a time limit? Is it 5 minutes every half an hour, or how quick can it respond?
It depends on the use cases. For example, in the Netherlands you can have the use case when you're informing users. You want to inform them in a decent way. You don't want to inform them that it is going up and down and up and down. So when the client wants to inform road users, we do a longer prediction, and we do, for example, we state 20 seconds, we fix the traffic light, because otherwise we can't inform. But if you look at optimizing the traffic light, then normally we do, when we don't inform, we do every 3 seconds, we make a new calculation. So we can change every 3 seconds.
That's interesting. So the amount of adaptability is in itself adaptive.
Yeah.
That's quite
It's highly adaptive if you don't inform. But yeah, if you look at how adaptive our product can be, and lay that besides informing the road user, that's a conflicting use case. Because
why Glosser is by Scoot's going to be. And things like that, more predictable methods of control are really going to take over. So.
Yeah, but also, for example, in the Netherlands, we see a lot of the times when a bus is entering a traffic light that all the traffic is all stopped for the bus, but sometimes it even may take 20 seconds. And what we really do, the difference between smart traffic and what we see on the street, is that for 20 seconds we can also give some other lights green, because they can just pass in front of the bus, or even go with the bus. You can do it more adaptively than it is now performed. And in the Netherlands we have a really already quite high adaptive traffic light, but yeah, we can even do better.
Could you pass the mic just to your left? Thank you.
Daniel C. Norfolk County Council. Obviously most traffic signals have speed discrimination built into them. How does your kind of road out, will tell the amount of seconds until it's going to hit red? How does that work? Because their vehicles, the traffic signals change dynamically, don't they, based on the approach speed? Are people going to speed up trying to beat this kind of 6 seconds to see that light's going to go red? That's going to encourage, isn't it?
Yeah, there's a big discussion in the Netherlands now, like with the human-machine interface, and when are we going to stop informing? Because indeed we had the discussion that if you inform the road user, for example, when you're allowed to speed up to an amount of speed, but then, yeah, you ask people to go faster to get the green light. That's a discussion, but we also, we just give the information, and that is within the Netherlands, it is with the apps that do inform the road user, because we have apps in the Netherlands, they also know exactly where the vehicle is. We at the traffic light, we don't, we know where the vehicle is, but we can't communicate exactly to the vehicle. But if you look, but that's a discussion we need to make sure that how you inform the road user, that you don't get, you want to be it more safe, but you don't want to inform the road user that you're getting a roller coaster or something at the traffic light.
When we had this discussion yesterday, we noticed there was a difference in culture between the British and the Dutch, and Sandra didn't understand the boy racer in his Vauxhall Corsa, so we'll talk about that one as we move forward, I guess.
Question over on Tony here.
Two questions actually. The first being, what was the previous system that was running? So you did some nice comparisons there, but if it was pre-bought beforehand, it's pretty easy to be. So I'm interested to know what the system was prior to doing this. And just from a network operations perspective, these systems are as good as the users that set them up. So I'm interested as to how you actually set that system up, how you fine-tune it.
You mean the old system. Yeah, it was quite funny. I had a presentation at a Dutch consultancy company, I think at the beginning of September. And I did the same video, and it was for the person who made the left part of the Rotterdam traffic light controlling. And he already told us he did the best that he could, but there were some things he couldn't deal with within. We have SWECO, but I think it's compared with MOVA. Like he can't deal with it in the Netherlands with the old way of controlling the traffic light. And because smart traffic was more adaptively, we can deal with the amount of traffic. But it was it was a good. It was externally made controlling of the traffic light. But yeah, I agree. You need to make a good insight and what do you control? What are you comparing to each other? Because if we choose a really lousy traffic light, of course we can do better.
And the user setup and the user setup.
The user setup within smart traffic. The user setup is there. We talk to the clients, what is their policy, and we make a first user setup. But there's a dashboard we give to the clients that they can just change their policy, what is important for them. So they can change the amount of how much more is the bus important than a car or a cyclist. And then smart traffic does do all the calculations and stuff. But that's the point of view where the clients can change how they control smart traffic. I don't know.
Any more questions? On the balcony there?
Just be loud. Just to echo the worry from down there that anything that told the driver to go faster would be an absolute no-no in any city that I was responding to. So watch that one in the UK. And the other thing I was worried about as well was you had an efficiency saving, you saved time for motor traffic, but on the same stats it showed that cyclists had delay, and whether you just shifting the delay around really to show efficiency. So a little comment on that would be good.
Yeah, that depends on what the client wants. So we are now aiming more with the cars, but if you want to do more for cyclists, it's really, some clients, they just I live in Utrecht in the city center, and they just think, well, cyclists, we do everything for cyclists, and when you are there as a car, just your problem. If you need to wait, I don't want cars in my city center, so. But that depends on how we configure smart traffic. But what we see, we are now doing a project in the east of Enschede, in the Netherlands, and we see that how the traffic lights are now controlled, that the cycling time is much longer, and we don't really have a cycle. So if we look at the time when all the parts of a traffic light are addressed, it's much shorter. So then you still can have that they have maybe compared to the other ones more delay, but the total time of waiting is shorter. So it's really, that's difficult to compare, but we tried to compare it just by what Visim tells us, the amount of delay. But you need to go on street and see what is happening. But especially in the Netherlands, the cyclist, we will never do that cyclists get really many more delay, because in the Netherlands cyclists are, cyclists are really important.
Any more? Well, thanks very much indeed for
Thank you.
the presentation.